Welcome back, grade 8s and 9s. Although online, I'm really happy to be teaching you this year, and we're going to start right off with the real number system. Now, the number system has been created just to identify what types of numbers you can get so that we can name them, we can classify them, we can see where they belong, and it is actually really easy to remember once you understand the number system. And you will see it's just the way as you've grown up. We've also introduced you, if you look at that diagram over there, we introduced you to the smaller bubble and then we expanded on that. So we're just going to have a look at what numbers you get and what their names are. All right, let's quickly have a look. So when you were very young, your teachers introduced you to the natural numbers when you were a toddler. So when you had to learn how to count, your parents wouldn't say to you, this is 0, 1, 2, 3. No, they would have taught you from 1, 1, 2, 3, 4, 5. Let's count these blocks. It's 1, 2, 3, 4 blocks. Those are your natural numbers. They come naturally. If I say to you naturally, just start counting, you would say 1, 2, 3, 4, 5. So those are natural numbers, and that is what you are introduced to when you are very, very little. Those are the first numbers that you are introduced to. Then, especially if you were in Tiger Valley, you would remember then you were introduced to Zero the hero. And I can't remember what connotation that had, but then to make children aware that there's also a number that there could be nothing, and that number that represents nothing is 0. And that is what we would call a whole number. So, is 6, 7, 8 a whole number? Yes, it forms part of the whole number. But if I say to you 0, is 0 a natural number? No. 0 won't be a natural number, but it is indeed a whole number. But 0, 1, 2, 3, 4, 5, 6, 7, those are all classified as whole numbers. And I'll show you now how to remember them, so don't stress if you don't get it yet. Okay, and then when you grow up a little bit, maybe when you get to grade 2, 3, you are introduced to integers. Integers to show that you can actually go into the negative. When you start owing people money, if you've got 5 Rand and you subtract 8 Rand, then you've got a negative 3 Rand. You owe 3 Rand. So then later on in the years, we introduce you to integers, but they are still nice whole numbers. I always call them the pretty numbers. There's no decimals. It's just 0 positive integers, 0 negative integers, and those are all integers. Right, then we took it one step up and we looked at the rational numbers. Now, a rational number is if you take a timeline and it's all the little bits and pieces in between. So in between all those numbers there are little decimal numbers, 3.5, 3.8, 2.4, 5.26. So there's lots of little numbers in between there, thousands and thousands, much more than the integers and that you can see there. So the only thing that's now the rational and the irrational numbers get split. So those little numbers in between there get split. You get the rational and the irrational. So the rational are the numbers that can be written as a fraction. Okay. Now a fraction where the top and the bottom, the numerator and the denominator, must both be an integer. So you can have like 5 over 8, negative 3 over 2, negative 4 over 5. Okay, so those both of them must be an integer, must be a nice whole number. Okay, so and obviously then the bottom is not allowed to be a 0 because then the number is undefined. Okay, but we'll get to that just now. Again, all right, so all those little numbers in between, they can be classified as a rational and an irrational or an irrational number. So the rational number, how do you know that that's a rational number? It is a number that can be written as a fraction, where the top and the bottom of that fraction must be an integer, not can be, must. And another way of seeing it, if you look at a decimal number, that decimal number stops. So if you say negative 5.28, stop. then it is a rational number. If you've got a number that let's say it's 10.353535353535, so it carries on, but there's a pattern. Can you hear? There's a pattern that's carrying on, and that will also then be classified as a rational number. So when you look at the decimal numbers must either stop or they must continue in a pattern. Okay, and then I'm going to explain the irrational now. All right, so the irrational numbers cannot be expressed as a fraction, although it can, but the top and the bottom won't be nice, beautiful integer numbers. So the top would be, let's say, 2 square root 3 over 1. So 2 square root 3 is not an integer. That's why then it won't be a rational number, but it would be an irrational number. If you look at the numbers as a decimal, if you think of pi, that's a very good example. It continues, the decimal continues, but there's no pattern to it. It's 3,142, I don't even know the rest, continues and continues, but it doesn't have any pattern to it, and it's just random numbers, and it doesn't stop. Okay, so that would then be an irrational number. So there you can also read there, cannot be expressed as a ratio of two integers, and it's not rational, obviously, because then it's irrational, and it have decimal expansion that do not terminate, which does not stop or repeat itself. Okay, so let's quickly, I always remember it as the impy. Luckily there's just three types. So it's the two imperfect, the two impies. I represented them as two imperfect flowers so that you can remember imperfect, impy, and pi. So those are the three types that fall under the irrational number system. So the first one would be the imperfect square. So a perfect square would be an example of square root of 9, gives you a nice whole number 3. But the square root of 13 is imperfect because it has a decimal number that doesn't stop. Can you see those three dots at the back? It means that it continues, and there's no real pattern to it. Hey, 3,0551275, those are just random decimal numbers. So it doesn't stop, it doesn't terminate, and there's no pattern to it. So that is an imperfect square, or in the same breath also an imperfect cube. So if you think of the cube root of 8, that's 2, but the cube root of 6, there's, if you punch it into your calculator, it's going to give you a big decimal number which doesn't stop, it doesn't terminate, or it doesn't have any pattern to it. And then the last one would be pi. So just think, rational is all those other little numbers in between that it can be written as a fraction. The irrational number is either imperfect square or imperfect cube or pi. Right, so let's quickly have a look. If you had to now classify, if I say to you in the test, 88, what type of number is that? Is it a natural number, whole number, integer, or a rational number? Then you say, okay, let's think. Is it a natural number? When you were young, natural numbers, you start counting 1, 2, 3, 4, 5. Yes, it is a natural number. So it belongs to it is classified as a natural number. But is it a whole number? Now, a whole number is where you add a 0, 0, 1, 2, 3, 4, 5, 6, 7. Yes, it belongs to there, because it will eventually, if you continue counting, you will get to 88. So yes, it is a whole number. Is it an integer? If you look at a number line, it's got negative, 0, and positive numbers, and they're all nice numbers. Is it an integer? Yes, it is. And then lastly, is it a rational number? Can it be written as a fraction with two integers both on top and at the bottom? Well, 88 over 1. Yes, it is a rational number. So it belongs to all four of those number systems, or those the classification of those numbers. So it doesn't have to belong to just one specific type of number. Okay, so please remember that. So next example. So if I say to you 0, is that a natural, whole, integer, or a rational number? Okay, remember that it can belong to more than one. So let's think. Is it a natural number? 1, 2, 3, 4, 5? No. So it's excluded from the natural number. Is it a whole number? The O, the 0 gets added? Yes, it is. Is it an integer? -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5? Yes, it is. And is it a rational number? Can it be written as a fraction? Yes. 0 over 1. 0 over 1 will give you 0, so it is a rational number. Okay, -200. So now we're starting to exclude some of or more of the types of numbers. Is it a natural number? Naturally start counting 1, 2, 3, 4, 5. No, it's not. Okay, is it a whole number? We add a 0 to the natural numbers. No, it's not. Is it an integer? Yes. Is it a nice integer? Is it a whole number with a negative in front? Yes, it is. And is it a rational number? Can it be written as a fraction? Yes, it can. -200 over 1. Okay, so -3.26. Let's have a look at that type of number. Is it a natural number? 1, 2, 3, 4, 5. If you say that number to a toddler, they will look at you as if you, I don't know, they won't understand what you're saying, because -3.26, they haven't learned that yet. So it's not a natural number. Is it a whole number where you add a 0? No. Is it an integer? So remember now, the integers are the nice numbers that you see on the timeline, -5, -4, -3, not the little ones in between. So no, it's not an integer. Is it a rational number? Okay, so now you have a look. Does it terminate? Does the decimal number terminate? Does it stop? Yes, it does, regardless if it's positive or negative. Okay, it could have been 3.26 or -3.26. Can it be written as a decimal? I'm sure it can be. If you put 3.26 in your calculator and you press equal and you put it over into the fraction mode, it will give you that it can be written as a fraction. So it is indeed a rational number. Okay, and then the only number that wouldn't belong there is the irrational number. So the square root of 12, you just say, is it an imperfect? So think of irrational, impiece, the two impiece, and pi. Is it an imperfect square? Haha, yeah, it's an imperfect square. So it would be an irrational number. Okay, but then you also get to the numbers that they are there, but they're not really numbers. They're non-real numbers. I call them the ghost numbers. Like you know they well, you don't really know they're there, but it doesn't exist. Although we have to classify them, we have to put them somewhere, we have to give them a name. So that is why we call them non-real numbers or imaginary numbers. Okay, and then a number like that would be where you have a square root and a negative underneath. Now you cannot get a negative under a square root, because a square root has to do with two numbers that are multiplied together. Two numbers that are exactly the same multiplied together should give you the number underneath the square root. So if you say 2 times 2 is 4, so the square root of 4 will bring you back to 2. Now, a positive times a positive is a positive, and a negative times a negative also becomes a positive. So nowhere will you have two numbers that with their sign in front multiplied together that would give you a negative. And that is why we call that a non-real number. So it's a square root where there's a negative under the square root. And then another, we use it a lot. You'll use it a lot in grade 10 going forward, where we talk about, especially with the, what do you call it? I'll get to it just now, but it's the infinity sign. So you say you count from 0 up to infinity. So that is also a non-real number. It's not a real number that exists, but we still need to work with it and classify it and use it as we still have to name it. So that would be also a non-real number. And then, just to remind you, anything divided by 0 is undefined. So if the 0 is on top, it's okay. So 0 divided by 5 will give you 0. 0 divided by 10 will give you 0. But if the 0 is at the bottom, so if the 0 is under, it is undefined. If the 0 is under, it is undefined. Or you can see it as a no. Okay, so that would then be undefined. All right, so just in conclusion, in summary, here's your top 5 real number facts one more time. So the real numbers include, they start there with integers, but I like to start with whole numbers, natural numbers, whole numbers, integers, rational and irrational numbers. Those are your real numbers. They exist. They're there. You can work with them. The number line contains all the real numbers and nothing else. So the number line, and please remember the little bits in between, it's all the numbers there and every little bit in between. Okay, every real number has a decimal representation. So a real number has a decimal representation. That's a fun fact that you can know. So 1 can also be represented with 1,0. If you take infinity, you cannot say infinity, 0, okay, or infinity, 1. Then real numbers can do arithmetic. So it means you can add, you can minus or subtract, you can multiply and divide with real numbers. And then there are numbers that are not real. We know them now. They're imaginary numbers. It's where there's a negative under a square root or infinity. And yeah, just remember, when anything is divided by 0, it is undefined. Okay, and that is it for today. Thank you so much for watching, and you must have a wonderful day, and I'll see you tomorrow again, or I'll see you soon. Okay, thanks, bye.